Greetings and welcome to an AP Create lesson. What we're going to work on is a few things. One of the biggest key points is the parent-child functions and how those work. And then along with abstraction, how do we put that into our programs and really understand how it works. So we're going to create a little program that's actually also going to demonstrate collision. So in creating this collision app, we're going to go over parent-child and abstraction. So there's a few things I need to do to get this all started, pieces that we're getting, because we're not focusing too much on the app and all the nitty-gritty. You should know how to do some of this. We'll explain as we get there with some of it. But the key is understanding the parent-child and the abstraction. So I'm going to copy some code off of another. I've already created this app. I'm going to copy code over as needed and explain it. A lot of the times I'll be typing, but sometimes I'll just copy code over. So if you see me bounce around, like in this case, this is the already done app with a lot of notes for myself. I'm going to copy the beginning code for us because it's not super critical to the abstraction and to the parent-child. Basically what we have is hide. That just hides the cursor so we don't see it running around, the turtle rather. And then we have square X and square Y, which is going to be the location, the bottom right corner of the first square, and then square X2 and square Y2 is the bottom corner of the second square. And I have some notes over here that kind of explains other dimensions, other places. But we're going to see when we actually put the squares, I'll show you what some of this stuff means. So the first thing we're going to do is build a square. That's the first thing we're going to do is build a square. Now I'm going to add a couple commands to it eventually for later on. But let's just build a simple square, right? So let's do pen up. This is going to make it so we can't see the cursor. We're going to do the move to, so we can move this square where we want it. And let's just do, I think 100 by 100. And at the end of the day, this move to is going to be the bottom right corner. So you kind of notice that 100 and 100 is square X and square Y. And then we're going to pen down, right? We didn't want to actually have the line running to it. So if we don't do pen up and pen down, you'll have a line scratch across the board to it. All right, so this piece right there is just getting it into position. The next piece is going to actually be the square. Now, we're going to move forward, and we're going to move forward 50. So our square is going to be 50 by 50, right? And then we're going to turn left, and that's a 90 degree for a square. All right. Now, if we run this right now, we're just going to see a line. All right, we see one line. Now, we have to do this 4 times, right? It'll turn left and just keep going around to make a square 4 times. 1, 2, 3, 4. Now, I could type this 4 times, but I'm going to go ahead and do my for statement real quick. So for var I equals 0, I is less than 4, I plus plus, squiggly bracket, enter, close the squiggly bracket, and then I'm going to indent these. So now when I run this, we have our square. Great. This code right here creates a square. So this is where we're getting to our abstraction concept. Right now, all of this code creates a square, but that's a lot of code. We could make it simpler. So what we're going to do is we're going to create a function, create square, squiggly bracket, go to the end, squiggly bracket, and again, highlight everything in here, hit tab, then indents everything. And now we have our function. So this is a function for this code. Now this is what's being abstracted, right? All this code creates a square. Now right now, it doesn't do anything. So remember, functions, they store code. To call the code, create square. Now let's run this one more time, and it creates square. So this is the abstraction, right? This is what's being abstracted, all this code, and now anytime we want to create a square, we just call this code. But right now, so that's abstraction, right? Let's leave it at that. That is abstraction. If you do something like this, you've created abstraction. This piece right here is an abstraction of all of this code, right? This is the easiest way to do and explain abstraction. Is now anytime I want to create a square, and you'll see that this will be a lot easier and even more beneficial when we add a little bit more functionality to it. But this base is its abstraction. But it only creates a square here. We want to be able to create a square wherever we want. So if you notice, we have square x and square y already here. Now I don't want to put that here because then I can only make square 1, not square 2. So in comes the parameters. I'm just going to send x and y. And then I'm going to replace this with x and y. Now you have to then send those parameters. So square x, comma, square y. And let's run this one more time. And again, just like we thought. That is still abstraction, and here is where it becomes the power of this. This is where the function and the abstraction has its power. If I copy this, Control V, and I add 2, I'm now going to do the second square. So let's reset this and run it. First square, second square. Now that we have these here, I'll kind of explain what all this gibberish up here is. So remember, this is the bottom corner. This is the bottom corner, and this is the x and y. This top corner is 0, 0. So down 100, well, x over 100, y down 100. That is this. Now, for this exercise, I'm going to say when the center collides with any portion of the top of this, we have a critical collision, and it's going to explode, right? So that's if that's at least half. If this point right here hits anywhere in here, at least half of this square is going to hit this and collide. Otherwise, it's going to be less. And you get, like, if just here hits right here, it's only going to be a fraction. We don't care about that. But mostly we're doing that because we'd have to write a couple extra if-then statements, because we have to say if this and this side hits anywhere in between this. For now, we're just going to focus if the center point hits anywhere between here. And you'll see what this means when we actually get to the collision point, why it's easier just to say if the center point hits it. And again, if you want to improve on this code, by all means. But for now, just to show you how it works. And to get that, again, you always got to think about variables. Square x minus 25 is this location right here, right? Square x minus 25 is technically this whole entire line, but right now it's that point right there when coupled with square y. So these are important things, which is, in this case, 75. So right now, at this second, this is 75. And that's important to know because this right here, this edge, remember it kind of runs all the way up and down. This is the x edge of this. We have the excess 200, right? So this corner right here is 200. So this line is 200, and I said it's 50 wide. So this line right here is 150. So this is 75. It has to pass past 150. The x has to pass. Now, we're going to focus on just checking for now when it drops and passes it, because that's another piece. But that's what this understanding up here is. Again, we're thinking about the collision because this is a collision app, so we can understand how collision works. So let's go ahead and start creating some of the pieces that we need for this parent-child concept. So one of the big things we need to do is create a program to kind of run this. So I'm going to create a function called run program. And inside of this program, we're going to need to do a few things. So this is kind of where the pre-logic goes in. I need to do a few things. I need to move my top square, and I need to check to see if there's collision, right? Those are the two big things we need to do, is go ahead and move and check for collision. So let's go ahead and do this with a loop, right? So what we're going to do is first create the move square function. So I'm just going ahead and call it move square. Spell it right. And then I'm actually going to run said, or create square. So function move square, parentheses, squiggly bracket, enter. And this one's pretty straightforward. So we want it to go down. So square y, again, that is this whole line right here. Square y equals square y plus 1. Now I did plus 1 again because this is 0 y, 1, 2, 3, blah, blah, all in 100. So right now, the very first time this runs, it'll make square y 101. And I remember that's too slow, so I'm actually going to make this 5. So this will be, well, we'll see what happens with 101, and then we'll try different numbers. So it'll be 101, and it runs again, 102. Every single time we move the square, it'll go down by 1. So this guy is going to give it a dropping effect. So let's, all right, and then the next thing we're going to do is we're going to create the square. And we're doing square 1, so I'm just going to copy square 1x. And remember, we just changed this. We just changed this. All right, so this is important to understand. With this move square, it was 100, 100. Now it's 100, 101. So it has moved the square. Now we still have to call the run program. We still have to call it, or it's not going to move it at all. But right now it's going to move it, and it's going to recreate it. So already we have our parent and 2 children. Now we're going to make these complicated enough that they actually pass the test for the AP challenge. But we have it. Here's our parent. This function run program, it calls move square right here, and it calls create square right here. So already we have a function that is a parent that these 2 squares, or these 2 functions rather, they really rely on the run program to do. This is the parent. If the parent doesn't tell them what to do, they won't do anything. So this is important to understand. This is a parent, and these are its 2 children. So basically, it's a function that calls a function. The function that calls the functions is a parent. The function being called is a child. That is all there is to that. So we'll make these more complicated so they actually will pass mustard, because you do need, so this one, I think technically maths it because it has math in it. And we're actually going to add another function as well to this. So it's going to have 3 children. The move square is going to go ahead and be the piece that we're going to look for that. So, all right. Let's go ahead and make this actually move. So I'm going to go down here and make a for loop for var I equals 0. Let's do it like 20 times. So I is less than 20. And then I plus plus, squiggly bracket, and we're just going to run program. Now, we're going to get some interesting results when we do this, and we might get an error if I type something wrong. But this will call run program 20 times and make this go down. So let's run it real quick. Right. So what just happened? One, it happened instantaneously, right? Right off the bat, all of that happened. It also just printed, which is why we got this like shadow effect. It's like it was moving but leaving a piece of it behind, is because it's what happened. It just kept printing over and over again. So we have two problems with this. One, we have a shadow, and two, it happens instantaneously. So what we want to do is go ahead and give this a little bit of timing. So I'm going to do a couple things. First, I'm going to create a start button. And two, I'm going to add a piece of code that's going to give us some timing to this. So first things first, let's go to design. Let's add a start button. Now this is going to probably be over the other one. But again, let's give it a btn for button start. So hopefully we can remember that name. Its text is going to be start. And then we're going to go ahead and give it its event. So I'm going to pull the event down over here. And I'm going to go ahead and ID it. It's btn start. And here's the line of code that we need to run time. So there's two you can use. One will work, the other one will not. So we have set timeout and set interval. Set timeout runs the function once at a certain time, then it's done. Set interval runs the function at that interval. So let's do this. Set interval, and it already knows that for us. So set interval, and then it takes two pieces. So the first thing is the program you're going to run. So run program. Notice I don't put parentheses there because that will make it run there. We just want it to run when it's called. So this right here, this run program, makes it run whenever it gets there. So we don't want the parentheses there. We do want a comma though, and we're going to give it how many milliseconds. So this is 1 second, but that'll make it go tick, tick, tick. So we're going to give it 100 milliseconds, which is 0.1 second. All right, so that'll run this every second. The next thing I'm going to do, and I'm just going to copy this from the other one real quick, is I'm going to hide the start button because I mentioned it's already going to be in our way. So we're going to hide the start button. I'm going to go ahead and get rid of this for statement, and we're going to see what happens now. We fixed one of our problems. So run. Remember, it says it starts in the way. We hit start, and there we go. So that's what it looks like when it runs. It's going to go down. So I'm going to reset that so it doesn't annoy us. And we have a couple things to worry about. One, it doesn't have, it still has that drag effect, right? It's still looking like that. So let's go ahead and work on that piece real quick. We're going to do in the run program, we need essentially to redraw everything. We need to redraw everything. So the first thing I'm going to do is I'm going to copy this code, but if we come over here to this code, I'll explain it real quick. We're going to change the color to white. We're going to make a dot that's going to just cover over everything. And then we're going to change it back to black. And then we're going to redraw square 2. So I'm going to copy that, paste it over here. Again, change it to white, that, and do a huge dot. That will cover everything. We'll change it back to black. It'll redraw square 2 in the original location because we haven't changed anything for square 2. And then it's going to move the square, and then it's going to recreate the square. Also at this time, this is where I'm going to change it to 5. Said 1 was really slow. Let's try it with 5. So we start. Everything's in the correct spot. We hit start. And now we have a nice, clean, moving square. All right, so that's movement. I think code.org went over movement a little bit. But this is in reminder, this is how you make things move. You just basically change their location, change their X and Y, redraw them, and then redraw everything. That's how we get everything to move. And that again goes back to why this abstraction is so important, because we can at any time just recreate it in a new location. So that's why the abstraction is so important. This piece right here is done. So we still have our parent, and this child is actually called twice in here now for square 1 and square 2, and then we have our move square. But now we need to do our collision. All right, we're going to do our collision. Now I'm going to do this kind of an interesting way, mostly because I'm not really going to end the game. I just want to see how this works. So, and I'm going to reiterate how to do a return function. So follow along with what I'm going to do here, because basically I'm going to create a function. Let me create the function first. Maybe this will help. And then I'll show you what I'm going to do right here. So let me go ahead down here and create our function. So function is collision. Actually, let's change this back to check collision. All right, so we're gonna call it check collision. And now we got a couple big things. So I'm going to run this so we can see our squares. All right. So first thing we're going to check to see is if this box has met this line, right? Because if it hasn't dropped to this line, it doesn't matter what its x is, right? Its x can be anywhere from side to side until it hits that line. As soon as it hits this line, we need to check, is this center location here? Is it here? Is it here? And that's what we're checking for its collision. Where is that center box? Now, again, you could code it so if any of this touches any of this, there's a collision. But for simplicity's sake, I'm going to say if this center location, because again, a critical collision is what we're really checking for, is if 50% of this is going to collide with it. Anything less than 50%, if this chunk over here collides, we don't care. It's only if 50% or more of it's going to collide with it. So basically, again, if this point right here hits anywhere on here, that's what we're considering a collision. So the first thing we need to check is if square y, again, that's square 1, that's the top one, is greater than square y2, the bottom one, minus 100. I'm going to squiggly bracket this, and I'm going to explain this real quick, all right? So again, this is square y. This line right here is square y. And it's moving down and down. That's our y plus 5. So it's getting bigger and bigger, 105, 110. Now, the bottom corner, let me move this start button out of the way for a little bit. The bottom corner right here, that is, again, where our x and y are for square 2. So this bottom piece of it is actually, and this probably should actually be 50. This bottom piece right here is the y's bottom. However, we want to check if it collides up here. So this is, as we can see right here, 400. So this top piece is 350. Now, I could just type 350 here because we're not actually moving this. But if you wanted to turn this into a paddle to make it like a Pong thing, so it comes down, it bounces back and goes off the surface, you could do something like that. You could actually move this around and give it up and down locations, kind of move it a little bit around and see if they collide. That you need this if it, otherwise, I mean, technically I could type in 350 right now and it would work for our purposes, but we're sticking with the concept of variables are there for a reason. Let's use this variable. So 350 or 400 minus 50, which equals 350. So if it's greater than that, and again, let's look at it. It's first it's 1.5, that's not greater than 350, 110, blah, blah, blah. 340 is not greater than it. 350 is not greater than it. As soon as it goes into it, 360 360 is greater than 350, it now is at a point where it can collide, right? So again, it can't collide. So let's go with it. Let's go and write our else statement. So maybe that'll help us kind of understand this a little bit. If it's less than 350, we're going to return too high. Guess I could return 420, but we'll do too high, right? So we're going to return too high because, again, it's too high. It can't collide. It's not possible for it to collide if it is above this y point. Again, and we can make this square go up because I wrote this as a variable. But if it is not greater than it, it is not possible for collide. So bottom line is that's why we have this function here. And this is why I'm explaining what we're doing here before we even put into the program. We need to check to see if it's colliding. It's not possible at this point. It's too high. So, however, now if it is greater, that means it's somewhere over here. It's somewhere over here. But we only care about if it's between these two x points. Now we know what this is. This whole x is square x2. This is square x2 minus 50. All right, and that's why, again, I have all this fun code at the top. So first we're going to do is our if statement. So if square x minus 25, and again, that's where I said square x is right here, minus 25 is that center location. If it is greater than square x2 minus 50 and square x minus 25 is less than square, that's why I copy so much, square x2, then we have collision. All right, what did I just say? This is what I just said. If this line right here, x, which at this point is 75, right? This line right here is 75. As soon as that becomes past x2 minus 50, so we have that right here, that's why I said the size is 150 to 200. So this is 150, this is 200. So if x1 is greater than 150 and less than 200, that means it's between these two lines, right? And they both have to be true. So yes, it's greater than this, and it's less than that. Now, you could write this some other ways, but this is the easiest way to write it. That means if it's between. So at this point, you've ran into the opposite. So we're going to return, nailed it. And then else, if it's not between that range, if it's over here or it's over here, else, we're going to return missed. Return missed. All right. Now we're almost there. We're going to go ahead and put this into the run program. So we're going to, there's going to be a lot of child elements. So you're going to get a good thing of this is the parent. There's going to be quite a bit of child elements to this. So this is going to give our complexity to the run program. This is why I'm doing it this way. I want to give complexity to run program. Remember, you either need math or need logic. So if check collision equal to missed, squiggly bracket, enter. And here's where we're going to need to create another function, but this one will be easy. End game, in this case, lose, right? So in this game, we want to run into the object. In this game, we want, and you can, however you want to create your programs, if you're using collision. In this case, if they run into it, you lose. So else, if, and this is important to be an else if. If we do an else here, it's going to win every single time you move. We want to check if it misses or collides. If it's too high, we don't care, right? So let's go and do our squiggly bar, enter for this. So we want to check if it hits or not. So basically, remember, these two pieces are only going to be returned as soon as we go below the Y, right? So when this comes down and it's below the Y, that's when we're going to start seeing these. So I'm just going to copy this again real quick. So check collision. But in this case, if it's nailed it, we're going to go ahead and run the endgame command again. Now the endgame command is not very complex. So, I mean, it's still a child. Let's be clear, endgame is still a child, but it is not critical, right? It's not going to be a very complex one. I mean, I guess it does have logic. So, all right, let's go over to it real quick. Last piece we're going to do, function, endgame, action. And again, because I'm sending lose and win, I'm going to go ahead and squiggly bracket, enter. And if action equals win, we're going to go in console log. All right, let's do this again. All right, so critical collision. All right, so critical collision, again, win. There's most of it on there. It's going to be a critical collision. And in this case, we can just do an else. In this case, it's okay just to do an else. We don't need an if. It's either you win or you lose. So in this case, we're going to console log again. Missed. All right. I'm going to pause real quick. I need to do something, and then I'll come right back. All right, I'm back. So where we left off, we have it now. There is an end game. You have an action, which we are sending a win or a lose action. If it's a win, then we have the critical collision, right? The critical collision is we've hit the check collision, says nailed it. They win. We're trying to hit this object critically. We get a critical collision. Otherwise, we miss. Now, again, remember, this only runs. We're only ever going to see these, the end game, if that's below it. So when we run this again, when this square, its bottom Y reaches this top Y, that's when we'll start seeing. Otherwise, it's too high. There is no scenario for that, so it does nothing when that happens. Now, I also noticed that we need to turn this into a function. Otherwise, it was a variable. I don't know why I did that. But now we should see this to work. Oh, that's why, because the end was over. So let's go ahead and reset this, run this, and start. And again, we moved at 5. You could 10 to make it go faster. But as soon as you got to that line, see how it starts saying missed. Because it's always going to be through. So I'm going to reset that. It's going to keep going forever. Obviously, if you were going to turn this into a game, you'd need to put more in the end game, right? You can make end game a much bigger thing. It could reset everything, put everything back to the top, randomly put the square in a new location, whatever you wanted to do. The end game would be where you could change to the end screen and allow everything to start over. But for now, again, my whole point is to show you the parent-child relationships, abstraction, and to kind of let you understand how collision works in just pure programming. Excuse me. All right, so the last piece we're going to do is we're going to kind of mess around. We already saw that this goes from 150 to 250. And if we change the starting location of this, 180, now remember, you got a minus 25, so 180 minus 25 is 165, which is in between this number. So if we run this again, you can already see the closure, it's closer. We start it, and now again, that middle point, you're aiming for that middle point. It barely gets that critical collision. Barely gets that critical collision. One more thing I'm going to show you how to do. I'm going to set this back to 100. is you can make it go left and right with a mouse. Now, I'm not going to show you how to use a mouse, and or you can use key presses. You can double check, go back, and code.org shows you how to do the key presses. But what you do is you listen, add the event listener for the keystroke, and you're gonna add what I'm gonna add. Now, you wouldn't add it here. You're gonna add it somewhere else. But I'm gonna do square x equals square x plus 1. All right. Now, again, you would, depending on which one, if you pressed right, this is what you do. If you press left, it'd be -1. And again, kind of like how we have the on events, you would do it in here. For demonstrations, I'm just going to show you that I can make this drift. And maybe this is, I don't know, wind current. We got a little parachute that's coming down, and it's got a little air current, and you need to kind of navigate and land on something, whatever you're trying to do. So let's go ahead and run this. Start. And is it going to hit? Nope. But at some point you can see, and this is where if we were continuing to build this program, basically what happened was it went like this, it was way below it, and then went over it, and then that's why it was critical hit, critical hit, critical hit, and then critical miss. Because we also didn't tell it, hey, you know what? There's a bottom to this. So if you're past the bottom, then you didn't have a critical collision. But again, my point was just to show you how to hit that target if it actually hits somewhere in there. So don't worry that obviously this follows, because again, your end game should also solve that problem too. As soon as it hits, it's end game. Either hits or doesn't hit, end game, and you're not going to let it keep going. But that's it, right? We did all of this. This is my parent function. It has logic to it. It calls create square. It calls move square. It calls check collision. It calls endgame. All of those are child. This has logic in it. This one has lots of logic in it. This one has really basic math in it. And this one we use as our abstraction. So this right here is abstracted and used and makes our program a lot better, so we don't have to call that code over and over and over and over again. All right, if you have any questions, please send them in. With that,